All right. So hi everyone. Good afternoon. My name is Chi-Hsien. I'm from IUIs, and today I'm happy to present our short paper, an intelligent assistant for mediation analysis in visual analytics. So over these years, visual analytics has become increasingly popular because it is very useful and effective to use interactive data visualizations to facilitate the analysis. Nowadays, many easy-to-use visual analytics tools are available for anyone to quickly plot a visualization and discover interesting trends. However, when it comes to causal inference, there's one challenge. The correlations shown on the visualizations does not necessarily imply the causation. So take an example, if we measure the shoe size of the kids and their math skills, then we will find there is a very strong positive correlations. But it is obvious that there is no causation here. Giving your kids a larger shoes doesn't automatically improve their math skills. It's just because the older kids have larger shoes and they have better math skills in general. So it is, this example is intuitive to understand, but in many cases, it is hard to determine whether the causation exists. For example, if someone collects the admission data of a university and finds that the male students have a higher admission rate than the female students, and now it is tempting to accuse the university that there exists a gender bias. However, the correlation might be mediated by some other variables. And maybe there is no gender bias in the truth. So this kind of causal inference is within the scope of mediation analysis, which tries to explain the causal relationships among three variables. Using our example, we're trying to explain that why gender have different admission rates by a hypothesis saying that maybe it is because the female applicants tend to apply to more competitive departments, and those departments have lower admission rates in general. As there are many visual patterns to consider, so our goal in this paper is to try to design a visual analytics interface that assists in making causal inferences in this kind of mediation analysis. So next, I'm going to discuss our design rationales and our actual interface design in an exploratory user study. So what are the important patterns we need to see in this scenario? Using our same example, we have three variables here. To generalize, we use x and y to represent the two variables of our target relationship, and use m to represent the variable that could be the possible mediator. So the first thing we can check is whether this pairwise correlation exists. For example, between x and y, do female applicants really have lower admission rates? And between x and m, are those female applicants to apply more to some departments? And between m and y, whether those departments really have lower admission rates? However, even if we find all these correlations exist, it is still possible that m does not influence y. In this example, the gender now is a confounding factor, and even m does not influence y, the confounding effects still makes a spurious correlation. So in statistics, to solve this problem, we can run a regression to fit y using both x and m. If m still has an effect on y when x is controlled, then we can be more confident that m actually influences y. Using visualization, we can do the similar thing by plotting the visualization using all the three variables at once. We can participate the data using x variable, and to check whether the m-y relation still exists within each x subgroup. In this case, we compare whether the m-y correlation still exists when x is controlled. Similarly, we can also see whether x-y correlation still exists when m is controlled. So this leads to two high-level design rationales. First, the three-variable visualization is necessary. And second, the consistency status of the correlations m and y and x and y are important. So to help people discover these important visual patterns, we design a visual analytics interface that will automatically recommend related important visualizations and help to detect the consistent or inconsistent trends, and also provide visual cues to help people interpret. Here's a screenshot of our interface. On the left part, it shows the variables that are being analyzed. And users can click on the variables to plot a visualization, which is shown in the middle. And then in the right part, the system automatically recommends important visualizations based on what is shown in the middle. To find the recommended visualizations and provide visual cues, we run several regressions tests in the background. The regression tests are used to test whether the current correlation being shown is significant and whether it is consistent when another variable is being controlled. For example, if the user selects x and y variable, we will regress y on x to test whether it's significant, and also regress y on both x and n to see whether it is consistent. And this additional regression corresponds to the 3-variable visualization, and is therefore will be recommended in the interface. Just like in our example here, the user selects the department and admission variables, and in the middle, the visualization shows that one of the departments indeed have a lower admission rate. And on the right, we recommend the 3-variable visualization and also provide the visual cues like the arrows here. Based on our statistical tests, the green arrows will show indicate the trend if detected. And the flat horizontal black arrows there means that there is no strong correlation. And we try to bring the user's attention to compare these conflicting visual patterns. And this can help them to distinguish what is the actual causal model behind this. Here we did an exploratory user study to get early feedback of our design. We conducted a within-subject study with 5 graduate students. The initial results suggest that with the existing features, they might make fewer wrong inferences and be more confident about their answers. And in the interviews, the participants mentioned that the ability to compare conflicting visualizations side by side and the chart importance scores helps them prioritize their reasoning effort. However, this is just a small size study, so further user studies are required to actually test the effects of our interface. So in conclusion, we designed an interface that assists the mediation analysis in visual analytics. The main interface features include detecting the consistent or inconsistent trends showing in the visualizations, and also provide visual cues to help them interpret the visualizations. This will be the end of my talk. Thank you very much.
Are there any questions? So what is the future work?
Yeah, so right now it is only for 3 variables right now. But of course, we want to extend the model to incorporate more variables. And also, right now we only use regressions. But maybe when more variables are being analyzed, maybe like path analysis or Bayesian networks, this kind of statistical framework can be incorporated into this system.
Excellent. Thank you.
Thank you.
Any more questions? If not, 1, 2, 3. Let's thank the speaker again.